So now in this video we're going to look at a common circuit fragment when you have alternating LEDs. So it's not done yet. Right now we just have two LEDs in series. There's the positive supply 1000 ohm resistor to the blue LED. LEDs are diodes. They have to be wired the right way to conduct, and in this case light up, because they're light emitting diodes. So the long lead, the anode, has to be more positive, short lead, the cathode, more negative, as you can see there. And we have the diodes connected end to end there, and a cathode to anode, and then we have the 220 ohm resistor going to the negative supply. So right now they're in series, currents flowing through them. Blue LEDs are just naturally brighter, as you can see there, and but they have the same amount of current going through them. That's the property of series. So when they're alternating, whether one is on or off, they will have an input to make them do so. So we have that jumper. That will be heading to an output. So this is a solid output of the power supply right there. Like integrated circuits and stuff, they'll have other components along the way, and so they may lose some voltage, but we're going to try to turn the blue LED on fully and turn the red LED off. So you can see we got positive supply there, and it wants to make the easiest way to the negative supply that it can. There you can see that the blue LED is lit up. So even though we do have a path this way, this is so easy that no current is going to go through the red LED right there in resistor to go to ground. So we have that on fully. So this would be a low output and going to ground, because we consider positive high and negative low. So again, now we're going to have a perfect output here, basically, where we go directly to the positive supply. So now there's no reason for current to go through that way when it just goes right back there. That is a direct connection. And so no currents going through that blue LED. It's all going through the jumper and then through the red LED and ground right there. It is pulling all of it. So in any case, we have the output. So as we said before, 5 volts. I have this above 20 milliamps because we were using more than 20 milliamps up there before, but I unplugged that circuitry. So you can see here that very little current is flowing through here. It takes about 5 volts to get these two LEDs to conduct at all. And so just a little current is trickling through for the most part. Now we're going to light the blue LED. So we want to go to ground right there. You can see we got about 2 milliamps of current, and you can see how bright the blue LED is. That's why I used a higher value resistor up there to limit the current more, and also it drops more voltage. There you can see we got a lot more current going through the red LED to light up about the same brightness that the blue LED was. Maybe like 6 times the current or whatever. That's why we have a lower value resistor there, plus it drops less voltage. So that's why I use those value resistors when I do these circuits. So in any case, that's it. Hope you enjoyed. Make sure you check out one of the other videos that I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.